So far we've been acclimating to pFsense's capabilities. We've explored the interface, we've allowed some time to elapse, and at this point our session should have timed out, requiring that we relog in, and that looks good. So in this section, let's just spend a little time looking at how to enable pFsense as a basic router, because sometimes all the extra features provided by these all-in-one solutions such as pFsense are not required. You may just simply have a subnet that needs a routing interface, perhaps through a virtualized interface as we have, to facilitate the movement of traffic between subnets or inter-subnet communications without having physical hardware. So let's just talk about basic routing configuration, because certainly any Linux-based system, and Windows for that matter, can function as a basic router without all of the extra bells and whistles provided. So when configured in this form, it functions as a router without firewall filtering. There is a way, however, to configure routing services with firewall filtering, and that is by disabling the default Outbound Nat. So let's just note that by default with this configuration, Nat is disabled. So let's just say note, ensure that subnet IPs or ranges are routable throughout environment. And typically for internal environments, this is not an issue. It's just a question on the internet in terms of allowing packets to flow. So essentially this means that if pFsense is an edge router, this configuration may not work, as you will not be able to route your internal RFC 1918 addresses out onto the internet. So it functions as a router. Nat is disabled, but let's just note that there's an option, so optional configuration, which let's say retains filtering but does not implement Nat. And that configuration is essentially filtering with Outbound Nat disabled. And perhaps we'll just talk quickly about that Outbound Nat. Let's take a look at our configuration here, where we can easily see what the default filtration looks like. We've since reset our router, so we're back up and running. And let's take a look at the NAT configuration briefly. So you got different types of NATs, which we'll look at shortly in a separate section. However, on the outbound side, there is an automatic outbound NAT rule that's generated for traffic, and it also includes IPsec pass-through for traffic that's sourced from the inside of the network to the outside of the network. So any traffic sourced from the LAN side is automatically NATed to the external IP address configured on the interface. And of course, the general status menu will show you that address. So 75.3. And if you have additional addresses bound, then you can write rules to bind the traffic to those ports and IP combinations as you see fit. But in its default configuration, the lone external IP address or WAN IP address is used as an outbound NAT address. And that can be confirmed by sourcing traffic from any of the internal nodes to anywhere outside of the router. So let's say on the WAN side. So for example, let's say before we make any changes, let's say we source traffic from LAN side and examine default NAT configuration. And this, of course, is what you would expect it to amount to, which is whatever IP address is tagged to the outside. So for many of the nodes, we can just launch a telnet, let's say back to a WAN side system such as 75.101 to a port such as 80 and just confirm the traffic. So confirm default NAT. So let's find a node, and we should be able to SSH from our shell. Let's find this instance back here, over to say Linux CBT ubu serve 1 from build 1. Let's reissue our connection. And we should ensure that we have a route
to 192.168.1.0 through 75.3, at which point we can SSH over to 1.102. And if SSH is available, actually it's not, we haven't enabled it just yet, and just to avoid going through firewall filtering prematurely, let's just navigate over to VMware and initiate the connection from there for the time being. Otherwise we'll be dibbling and dabbling into sections prematurely, so we'll just do it from the console for now. So gaining the perspective of a local LAN node in a virtualized environment is rather straightforward. Otherwise, you typically have to out of band or physically access the node. So say we take ubuserve1, get to its console, and from here, launch a connection back. And its default gateway, by the way, let's netstat.rn, is 1.1, which means any traffic leaving this node will essentially hit 1.1, and then the WAN side will know how to find 75.101. So let's telnet back to 192.168.75.101, port 80, and we expect this connection to occupy 75.3 on the WAN side. So let's pop back over to here, and let's do a netstat ANT grep 80. And there we see the connection coming in using the WAN side interface IP address of 75.3, using this port to connect to port 80. And any such socket source from the other side will result in the same natting. That's no surprise, of course. So if we repeat this, let's say for port 22, and within enough time, double check port 22 from the sockets list, we'll see 75.3 is in on port 22. So that's your default configuration. And however you alter the external IP addresses associated with your NAT configuration will determine the IP addresses that are used to access outbound services. And you can vary them. You can use multiple IP addresses, one IP address, as long as you don't exceed the available ports, which is generally not the case, and so on. So now, how do you route without, and by the way, when you make reverse connections, those connections come in as a source IP address as well. So from the local system, any port that's available will show up on the other side. But we haven't written rules yet to map to specific nodes, so we'll just work on the assumption that traffic's generated from the LAN side. So to enable routing, that means for any packet, by the way, if you're ping, etc., it'll show up as the external address. So just quickly back over here for a moment to the console. So despite protocol, let's see if we can terminate this session here. So if you just simply send a few packets ICMP to 192.168.75.101, these packets are then rewritten as 75.3 when communicating with 75.101, and a TCP dump would reflect that if we had it running. So now back to our other node. Let's enable routing, which is what we wanted to do. So that's been confirmed. So to disable firewall filtering and enable routing only, and of course confirm. So to do this, we'll navigate into System, followed by Advanced, followed by Firewall Nat, and then we'll select Disable all packet filtering. A reboot is not necessary. It just drops the firewall filtering rules. Let's save this. Let's go back into our browser. Into Firewall Nat. And this is disable all packet filtering. So it turns it into a routing only platform, sending traffic through n number of interfaces configured. And it disables NAT. So again, be sure that your IP addresses are routable across the networks that pass through this pFsense or your routed instance. So now it's a router. So any firewall rules that are in place, you can check firewall rules for any of the interfaces. So for example, we currently permit ports 80 and 443 for the sake of managing, and bogon networks are blocked on the WAN side. And on the LAN side, all packets are allowed out. And we also see that This is an anti-lockout rule for 443 and 80 that's included by default. Some rules are included by the interface by default just to avoid any potential issues. So these rules will absolutely be ignored. So now when we source new traffic from that remote side, let's go back to the VMware console, for example, and say we telnet into port 22. This comes in as its actual IP address, which is 168.1.102, and that can be confirmed from this side as well. Let's take a look at 22. Now you see the traffic coming in as the actual IP address, and because it's routable, it works as expected. Now how about the reverse axis? What if we try to send some packets to 192.168.1.102? Notice that it flows through directly to that remote side. Is it a fluke? Is it a mapping that's being honored, or some other potential connection between, say, the WAN side and LAN side? Well, we can always bring up another node to confirm whether or not that's the case. But note, the connection shows up as expected. Now, let's try to telnet before we do what we just mentioned into 1.102, let's say port 22. There's SSH, which was unavailable before. Now let's go back over to the console, the VMware console, see how that's reflected. So we should be able to kill this outbound SSH connection and execute a netstat ANT grep 22, where we should see 75.101 connecting to us on port 22. So that's working as expected. That looks good. So with routing enabled, firewall filtering rules are disabled by default. That means all packets will pass as expected. And that means there's no filtration. And again, if you retain firewall filtering but disable outbound NAT, you effectively have a firewall or a router with firewall rules. So without NAT, that is. So that's an optional way to do it. It's the way, for example, your typical Cisco Juniper router can be configured to firewall but not NAT. So NAT's usually an add-on service that's included. So if you just need to route, it's that simple. Let's bring up some of the other nodes that we've pointed out during our discussions. For example, BSD1, which should get a DHCP. And by the way, the DHCP service still functions, so you don't lose the services on the LAN side, such as DNS mask, DHCP, NTP, or any other service for that matter. So we'll bring BSD1 up and see how it behaves. And usually with VMware, it helps if you bring things up one at a time, just to be careful. We'll watch this console to see it come up. And this should be up momentarily. It'll obtain an address which can be confirmed from our interface, of course. Let's pop back over while that comes up. And in our interfaces, you can have a look at the logs to see what DHCP leases have been loaned to addresses, and currently it shows no addresses. The 102 address was acquired before the system restarted, so it doesn't show. But if you do a show all configured, you'll see old leases as well. Here's BSD1, which has just come up, and it shows its range. By the way, note how short the leases are. So this runs from 15.14 to 17.14 on the same day. So essentially, or effectively, the leases default to 2 hours. So that's a short period of time, or 7,200 seconds. So the other node's now 103, and we should be able to send some packets to it. Let's 92.168.1.103. That receives it, but there's no immediate trace. So let's telnet to 103 to, let's say, it's port 22. It should be running SSH services, and that shows OpenSSH 6.4 FreeBSD. And the release, it's 10x release. And of course, from the console of that node, we can confirm as such by logging in. So this should, of course, now be 103. Netstat AMP TCP should show that the node has connected from 75.101 directly to 103 on its port 22, delimited with a dot, a period instead of a colon. And certainly ifconfig will reflect that the node's configured with 103 and it's DHCP enabled. The DHCP configuration on BSD systems, just cat etcrc-conf, and you should see the reference to the interface. So let's, for example, grep EM0, and you'll see that it's configured to obtain its address via DHCP, and that's why it's picked up that 103 address. And conversely, if we source packets out, so telnet, say, to 192.168, just as we've done on the Linux side, to 10, let's say, 1 port 80. That'll show up with its natural IP address as well. And on this side, if we can just terminate this session and execute a netstat ANT grep 80, we should see that 103 has sent its packets. And of course, this begs the question, what about internet access? We're doing all things local now. Well, ultimately, the upstream router 75.1 will NAT any traffic leaving the network, whether it's considered WAN by pFsense or LAN by the upstream router. So let's say 3. So we've tested, let's say as B, tests various communications via pFsense. And let's just say as 3 as we extend this to test upstream internet communications. So what happens in this case? Well, let's just note that upstream router will ultimately NAT any traffic leaving the network destined for the net. So if you have a series of routers, pFsense instances, Juniper, Cisco, Huawei, or any other type of routed interface, ultimately at some point NATing should take place. So from the perspective of, say, let's maybe go back to the BSD box, we'll just make a connection outbound. First we'll try to dig it. So let's do a dig dev1 linuxcbt.com. And so long as it comes back, we should then be able to telnet to dev1 linuxcbt.com, port 80, for example. And the upstream router should NAT this particular request. It should go out as its actual address. Now, if it doesn't NAT it, it means that the upstream router is not familiar. So that's the problem that we're facing here. So we're trying to route traffic, but the upstream router doesn't have a route back into 192.168.1.0. That's the problem. So it doesn't have a route back in. So let's just add as a note that you should ensure that your subnets are all tied somewhere. So note, upstream router may fail to, let's say, complete TCP sessions due to, let's say, missing route back to pFsense controlled subnets. And that's the case here. So, i.e., our current upstream router has no knowledge of the 192.168.1.0/24 subnet. And that's why it's not completing the session. So we're effectively creating a half session, and the router has no way to bring that traffic back in. So to make that complete, we'd have to tell the upstream router to use 192.168.75.3 as the internal router that's responsible for routing traffic back. And then it would, of course, NAT the traffic coming back in. So in a separate window, we've gone ahead and added that static route. So let's just note as one of our tasks, add static route to upstream router, pointing back to 192.168.1.0/24 via 192.168.75.3, and then retest. So retest upstream internet communications. Let's see if that telnet outbound will work, and it should. Let's head back over to, and we could do so with SSH or directly from this finally gave up. Now notice it works to dev1. So of course, if we confirm this from some other window, maybe this system here, let's SSH as root, dev1 linuxcbt.com. Maybe we'll just execute netstat ANT grep 80. And that'll ask me to accept the key, and then we'll wait for this to come back, see if it'll run the command for us. And there it comes back. So we should see a port 80 connection inbound, and there it is. This is our external IP address. So this is the connection. We came in on 22, so this must be the port 80 that we've just sampled on the other side. So now, because the route's in place on the default gateway, any of the nodes should be able to communicate. So, for example, we can now SSH into 192.168.1.102. So now we're back on this node. It's, of course, IPs on the 192.168.1.102. That's that RN. 1.1 is its way out. And similarly, a telnet to, say, dev1 like CBT.com, port 80 will also work. So it's just a matter of adding a static route or using some sort of routing protocol such as RIP, OSPF, or otherwise if your environment calls for it. If it's just one or two subnets, then static routes are still the way to go. It's the simplest way to connect these networks whenever you need to route traffic in and out. So let's reset our configuration. So reset configuration to support NAT and firewall rules. And that's just going to be a matter of system advance. Firewall NAT. This enables the configuration, undoing it as we did earlier. Let's click Save to apply the changes. And now any traffic outbound from any of these nodes will be natted to the external address, which we again can confirm. Now this SSH session will break because we don't have a firewalled way or rule of getting in. So note, instantly terminates and sometimes freezes existing connections because of lack of firewall rules. So the only firewall rule that's defined allows 80 and 443 access directly to the management interface of 75.3. What about the far side of the router, 192.168.1.1? That's the far side, and notice it's giving us access. So near side, far side, it's allowing us in. If you take a look at firewall rules, you'll see the rules that are specified for this item. And let's just give this a bit here. And there we see the two rules, 80 and 443. So coming off of 75.0, destined to anywhere, whether it's the near side or the far side, it permits the traffic through. But in terms of SSH to any of the nodes within, we'd have to have one-to-one mapping. So for example, port 22 on the external address 75.3 would be mapped to one and only one internal node on the 192.168.1.0/24 subnet. So we have to, in a natted situation, make our decisions carefully, no differently than connecting to the edge to the internet, whereby once you've dedicated a port to a specific node, that's it. It's tied to that node in a one-to-one mapping in terms of ports or IPs if you choose. So you can use pFsense essentially as a router, and that's not a bad way to do so. Before we step away to the next subject, let's just be sure that connection's sourced. So say, for example, and we could, of course, get to dev1.cbt.com. That's going to be, or anything on the internet, but let's just telnet back to 192.168.75.101 port 80, and then confirm that from, say, this side, which should have diverted to this node. And the connection's actually frozen, so we'll terminate this session. Open a new session on 75.101, followed by a netstat ANT grep 80, and we should see the natted address 75.3 coming in on port 80. So that's looking good. So we're back to the original configuration. Firewalling is in place, and we'll move on to some other subjects now.